In the previous video we saw the working of PMOS and working of NMOS. So now we will see the difference between them. Like if you talk about NMOS and PMOS, in NMOS the source will be at higher potential, at lower potential. In PMOS, source will be at higher potential. In NMOS, our drain will be at higher potential. And in PMOS, drain will be at lower potential. And direction of current in NMOS will be from drain to source, and direction of current in PMOS will be from source to drain. Here our charge carriers are electrons. Here our charge carriers are holes. So, source in the NMOS will be at lower potential, and in PMOS it is at higher potential. Drain in NMOS is at higher potential and it is at lower potential in PMOS. And direction of ID, that is direction of current in drain current, in NMOS is from drain to source, because here the charge carriers are electrons, and we know that whatever charge carriers is, like whether it is hole or electron, it always travels from source to drain. So if electron is moving from source to drain, our current will be flowing from drain to source, because the direction of current and direction of movement of electron is opposite. And in PMOS, the direction of ID is source to drain, because here the charge carriers are holes, and holes travel in the same direction as that of current. Now we will see the symbol. So if we talk about NMOS, NMOS means N-channel MOSFET. It can be depletion type. If it is depletion type, it will be shown like this. This is gate, this is drain, this is source, and this is the body terminal, and this arrow will be like this. And in enhancement, this is gate terminal, this is drain terminal, this is source terminal, and this is body terminal. And arrow will be again like this. And if we see here we have dashed line, because in enhancement type channel is not present. Here we have to create it by applying some voltage at the gate. So this dashed line represents the absence of channel. And here we have solid line, so it represents that in depletion type MOSFET, channel is already there before applying any gate voltage. And this arrow comes from here, like if we see N channel, then this is N, drain is of N plus and source is of N plus and substrate is of P. Substrate. So, and here we have the body terminal. So if we see the imaginary diode here, it will be like this. Drain is of N type, so our N side of the diode will be here, and the substrate is of P type, so the P side of the diode will be this side. So it is looking like this is the body and arrow is like this. So if we tilt it like this will be the body and this is the arrow. So this is here, and same thing is here also, because it is also for NMOS only. But the difference in these two is that here we have dashed line, and which shows that there is absence of channel. Now, if we don't talk about depletion or enhancement type, there are two common type symbol for both the types, like, and it is shown like this. This is gate terminal, this is drain terminal, this is source terminal, and this is the arrow. And the second one is like this. Just drain terminal, source terminal, gate terminal, and no arrow or anything. So here this arrow represents the direction of current. Like in NMOS, our direction of current is from drain to source. So this arrow represents that direction of current. But this is just a symbol. We can't rely on this arrow for the direction of current. Like we have to find out the direction of current whenever it is asked. So, and here it is just gate terminal, drain terminal, source terminal without any arrow. This is the symbol for NMOS. Now if we see for PMOS, there will be some difference. Like this. Only the change of arrow in the depletion type and enhancement type, and here also we will have the change let me draw it from the starting. So if we draw the depletion type PMOS, it will be like this. Here we will draw the source at the top and drain at the bottom, because in PMOS source is at higher potential, and the one with higher potential we generally denote it at the upper side. Like we have always seen like this. If it is 5 volt and it is the ground, then we have seen like this. We have not seen like this. So the common representation type is like the terminal with higher potential is shown at the upper side. So here, since source is at a higher potential, so it will be shown at the upper side. So here, and this is the body. And in PMOS, if we see, our drain is of P plus type material, our substrate is of N type material. So our imaginary diode will be like this. So we can see that this is the body terminal and arrow is like this. And if we tilt it, it will be like this. So here we will have the arrow in this PMOS. Now if we talk about the enhancement type, in enhancement type the only difference is that we don't have the channel present without applying any gate voltage. This is the gate terminal, this is the drain terminal, this is source terminal, and this is body terminal. And if we talk about the common symbol, it will be like this. Source, drain and gate. Again in PMOS, if we see, the direction of current is from source to drain. So it will be like this, source to drain. So this arrow represents the direction of current. And if we talk about another symbol, it will be like this. Here we will draw a circle, and the presence of this circle says that it is the symbol for PMOS, and if we just remove this circle, then it will be NMOS. So this is the symbol for NMOS and PMOS. Now we will see some examples on how to determine which is the drain, which is the source, and the direction of current. Like suppose we are given like this. And this is 6 volt and this is 4 volt, and this is gate, we all know that. Now if we have to say that what is the drain terminal, which is the drain terminal and which is the source terminal, and what is the direction of current in this, first of all we can see that it is in NMOS by the presence of this arrow. Then in NMOS we know that the drain is at higher potential, so this 6 volt will be the drain, so we can write here drain. And we know that source is at lower potential, so this 4 volt will be the source, so we can write here source. And we know that the direction of ID in NMOS is from drain to source, so it will be like this. But if we change it, like this is 4 volt and this is 6 volt, and now we have to identify which is drain terminal and source terminal and the direction of current. Again we can write here that drain is at higher potential, so drain is at 6 volt, so this will be the drain here. And source is at lower potential, so source will be 4 volt, so this is the source. And we know that the direction of ID in NMOS is from drain to source, so this time the direction of ID will be like this. So we don't rely on this arrow given in the symbol. We have to identify the direction of current by first identifying which is the drain and which is the source. Now if we talk about PMOS, for PMOS our arrow is like this, and let us suppose it is again 6 volt and it is 4 volt. If we have to identify which is source and which is drain, we can say that in PMOS the drain is at lower potential, so 4 volt will be the drain, and source is at higher potential, so source will be 6 volt, and direction of ID in PMOS is from source to drain. So the direction of, here we can write source, here we can write drain, and direction of ID source to drain, so our direction of current will be like this. This is the direction of current. And now if we just flip it, like if we write it 4 volt and this to be 6 volt, again our source will be 6 volt because source is at higher potential in PMOS. So this will be the source, and drain will be 4 volt, so this is the drain. And we know the direction of ID in PMOS is from source to drain, so this is the direction of ID here. So we need to remember this, that we don't rely on this arrow for the direction of current. We need to find out first which is the source terminal, which is the drain terminal, and according to that we have to see that the direction of ID in PMOS is source to drain, and direction of ID in NMOS is from drain to source, and then we can find out the direction of current. So this is it for today, and we will see some questions in the next video. Thank you.